Okay, so the approximation that we are going to add is called the Huckel approximation. So I think if you were German, you would pronounce this Hückel, but in America, we call it Huckel. And in the Huckel approximation, we only include nearest neighbor interactions. That is to say, if you look at this expression for the expectation value of the energy, it involves two wave functions, one that's centered on the origin here, and another one that's centered on every possible lattice point, including the origin as one of them. So when the Hamiltonian operates on this function that's centered on the origin, that gives you a result that goes to zero once you get very far away from the origin. And then you're multiplying it times some other wave function that's centered on a different point. If Tj is a large displacement away from the origin, that's going to give you zero, because every place that h operating on phi of r is non-zero, that's only non-zero close to the origin. So if this is a wave function that's centered on a point far from the origin, this is going to be zero close to the origin, and this is going to be zero far from the origin, so the integral is just going to be zero. So that's the justification for the Huckel approximation, but it is an approximation. Sorry, we're missing a vector sign there. However, as is the case with most approximations that we make in physics, it allows us to get some important insights. So if we put this approximation into our expression for the energy of the tight binding wave function, the expectation value, we get that the expectation value for the energy using the Huckel approximation and the tight binding, I'll just abbreviate that as TB, wave function is equal to, so in this sum, there's one term in the sum that's kind of unique, which is when Tj equals zero. So I'm going to split that out, and then we'll have the rest of it in a separate term. So we have the integral over all space. When Tj equals zero, this exponential just gives us one. So I have phi star of r, because Tj is zero for this term, Hamiltonian operating on phi of r d cubed r. But then I have to add in all the other terms, but now in the Huckel approximation, we're only including the nearest neighbors. So instead of summing over all j, we just sum over the nearest neighbors. I'll abbreviate that as NN, nearest neighbors to the origin of e to the minus I k dot Tj integral over all space of phi star of r minus Tj Hamiltonian operating on phi of r d cubed r. Okay. So that's an important enough result to put a box around, and that's our expectation value in the Huckel approximation for the tight binding wave function.